In this video, I'm going to cover about the normal distribution. We'll look at what is normal distribution. I will show you how to use a calculator to do the calculations. And we'll also look at some basics, how you can read the data from a bell curve. So let's get started. The normal distribution curve looks something like this as shown in the diagram. It's also called as a normal curve. Sometimes they call it as normal distribution curve. In a normal distribution curve, there are two parameters that always need to be mentioned. One is the mean mu, which measures the center of the distribution. So your mean is at the center here. If I draw a vertical line here, this is denoted by the letter mu, which is a Greek letter. And the second parameter is the standard deviation, which talks about the spread of distribution from the mean. So a normal distribution curve will be something like this. It's advisable to draw a quick sketch before you attempt questions, because then you understand the way the question can be interpreted, and that will help you to come up with your results. For any population that is normally distributed with a mean mu and standard deviation sigma, approximately you will see in these diagrams 0.68 or 68% of the population will lie between the mu and one standard deviation, which is something here on both the sides. So 68% of your population of the data will lie between these 2 points. 95% of the population will lie between the mu and two standard deviations, which is here. So it includes these two areas and these two areas. So all the way from here until here, 95% of the population will usually lie in that area. And if you're looking at three or third standard deviation, then we are talking about 99.7% of the population will lie between this point and this point. The proportion of data values will lie within different ranges relative to the mean. And as you can see here, I've labeled it. This is your mean. This is one standard deviation. From here, from the mean to this point, it's two standard deviations. From the mean to this point is three standard deviations. And this is a symmetrical graph. So therefore, whatever is true on the left will also be true on the right. So let's start working with some examples now. And that will give you a very clear understanding of what you need to do. Okay, the first example. A sample of cans of peaches was taken from a warehouse, and the contents of each can was weighed. The sample mean was 486 grams with a standard deviation of 6 grams. State the proportion of cans that weigh between 480 grams and 486 grams. The first step that you have to do is always draw a sketch of a bell curve like this, and your mean is 486, so the center line is 486 here. Your standard deviation is 6 on either sides, and you can subtract 6, add 6, and this is the diagram we get. And if you recall from the first diagram, each area has a certain percentage. So from this diagram, you can see that the proportion of cans that weigh between 480 to 486 is in this, under this curve in this area, and that accounts to 34.13%. I'll show you how to work it out using a calculator. In many exams, calculators are allowed, so let's dive in straight and use the calculator to do it. So my first thing is to go to the menu, go to stats, go to distribution, normal. NCD is normal cumulative distribution. Here I have to type the lower limit, which in my case is 480. The upper limit is 486. The standard deviation is given as 6. And the mean is 486. When I click on execute, this is the value that I get. It is 0.341. So that is the probability. If you are looking at probability, this is the probability of getting cans between 480 grams and 486. One more point I must make is under the graph, the total probability if you count will be equal to 1. Looking at the diagram shown below, you can see that the proportion of cans that weigh between 480 grams and 486 grams is 34.13%. Similarly, question B says more than 492. So here you can see 492. Everything to the right of it will be included. Therefore, I will add 13.59, 2.15 and 0.13%, and that gives me 15.87% of the cans are expected to weigh more than 492 grams. Another example here is from the textbook. A school's grade 12 student sat a mathematics exam. Their marks were appropriately measured using a normal distributed curve with a mean 75 and standard deviation 8. Copy and complete this bell-shaped curve, assigning scores to the markings on the horizontal axis. So this is a typical bell-shaped curve. You will start off with the mean. Our mean is 75. So here you'll have a 75 labeled. And then every standard deviation is 8. So I have created a diagram below. Subtract 8 and label it here. Add 8 and label it here. So this is your 1 standard deviation, this is your 2 standard deviation, and this is your third standard deviation. From this diagram, it's extremely easy to do the calculations and answer the questions. What proportion of students would you expect to have scored more than 83? As you can see here, all these would qualify. So I would add 13.6 plus 2.1 and 0.1, and that is the approximate value I'm getting. What proportion of students would you expect to have scored less than 59? So less than 59 are these two areas would qualify, and I would just use a calculator and I would add those two numbers, and that should give me the result. So this value and this value would qualify for that particular question. Between 67 and 91, between 67 and 91, which would make it this area, I would add this area obviously, and I would add this area. So this would cover the area under the curve between 67 and 91, and that gives us an approximate value of 81.85%. So as you can see, it's quite easy to read the values from a graph once it is labeled. Example number 5. The height of female students in a university is normally distributed with mean 170 centimeters and standard deviation 8 centimeters. Find the percentage of female students whose height is between 162 centimeters and 170 centimeters, between 170 centimeter and 186 centimeter. Again, first advice is to sketch a graph. It does not have to be accurate. Sketch a graph with a bell shape like this. And as you can see from the graph, I'm looking for 162 to 70, which is in this area. And this is how we write it actually. Probability of x being greater than 162 and less than 170 is 34.1%. So we're talking about if this is a 100% curve, that's what it represents. If we add all these values, you'll get it as 100%. So 34.13% of the students will qualify under this condition. The second example is between 170 and 186. So 170 and 186. Obviously, we are talking about using these two areas. So that's what I did here. Probability that x is greater than 170 and less than 186 is approximately equal to, you add this value, and this is your answer. If you want to find the probability for the same two questions, I'm going to show you how you can do that using a calculator. And mostly you will be using a calculator in your exam. And this example is extremely useful to solve many questions that are in line with the board exams. Okay, so let's have a look at the calculator and see how to do these calculations without remembering all these numbers that have been shown on the screen. So let's get started now and see how to do it with a calculator. You go to stats, you go to menu, go to stats, select distribution, normal, and NCD. So in our case, the lower level is 162, the upper level is 170, the standard deviation is 8, and the mean is 170. If I execute, you'll see there I'm getting 0.34134474. You can give the answer to three significant figures. And you can see that this answer matches this answer which we saw in the first case. Similarly, if you're looking at the second example, I'll go back to the menu, stats again, go to distribution, normal, NCD. I'll change the values to 170, which is the lower height, and the upper height is 186. And the answer is 47.7, as you can see there, matches this answer. So you can do this using a calculator. Okay, I'll show you how to do the calculation for 5B using a calculator. Go to stats, go to distribution, normal, NCD. Now the value is less than 154. So my lower can be 0 and the upper is 154. And you can see this answer is 0.0228, which can also be calculated manually. If you're talking about one less than 156, even 154, that means you're talking about these two areas will qualify. So you can do it without remembering the numbers, as I said before. Do the calculation using a calculator. So your answer is 0.0228. For question number 5B2, find the probability that a chosen female student has a height greater than 162 centimeters. As you can see from the diagram, these areas will qualify. All these areas will qualify on the right. One way to do this is to add up all these values. Another way to do it is you can add all the values to the left and 1 minus that will give you the balance on the right. So you can do any method that you wish. What I try to do in this example is I try to find out what is to the left of this desired height, and then one take away that answer gave me the final answer. So let's see how to calculate using the calculator. I go to stats, to distribution, normal, CD. Okay. Now what I do is, let me try this out. Let me work out what is to the left, and then 1 minus that answer should give me the value, or I can do it the other way around. Let's do it this way. The lower value given to me is 162. The upper is, just put a bigger value there. Standard deviation and mean stays the same, fortunately. And now let's execute and see. Okay, now let's calculate the probability that the student's height is greater than 162 centimeters. I go to stat, I go to distribution, I go to normal and CD. And now my lower value is 162. For the highest value, I'll just put a big number, 999. The mean and standard deviation is already set because of the previous question. And this is your probability, 0.8413. Okay, let's look at question number C now, 5C. For a group of 500 female university students, how many would you expect to be between 178 and 186 centimeter tall? So they're asking you the number now. Let's look at the percentage. 178 to 186 is this area, which means 13.59% of the population will qualify. So then I have done the calculation here to save time. 13.59 over 100 times 500, so that's the population given to us, and you're getting 67.85, which is approximately equal to 68 students. So 68 students would qualify under that specifications that has been given in the question. Now let's look at 5D. Estimate the value of K such that 16% of the student population are taller than K centimeters. So we here the area is given to us. So the area under the curve is given to us. Try to understand the scenario. The area under the curve is given to us, and we have to find out this value now, these values which were given to us before. Now we have to find out for what value 16% of the students would come under the bell curve. To do this, I'll go to stats. This time I'll go to distribution, and now because the area is already given to me, I'm going to inverse function. Now in the inverse function, I'm going to choose the tail. Tail is when you're reading the data from the left side. This is supposed to be the tail, and this is supposed to be the head. I'll go to stats. I'll go to menu, click on stats, click on distribution, normal. As I mentioned before, since we are finding out the number and the area is given to us, when the area is given to us, go to the inverse function. Now we are looking at greater than, taller than K. So you need to select the right as your tail. If it was lesser than, then you can select left as your tail. So now I'm saying my tail is on the right. The area under the curve is 0.16 because this is percentage. In terms of probability, it would be 16 divided by 100, which is 0.6. The mean 170 and the standard deviation is already given to us. Now when I execute it, approximately 178 students, 16% of the students would be taller than 178 centimeters. They asked us to find out what percentage of the students. The question was to find out the height where 16% of the students would qualify. So looking at the question, 16% of the female students will be taller than 178 centimeters. So that is the way you calculate it. I said I'll give you two tips. The two tips are, if the area has to be calculated, go for normal distribution in CD. If the area is already given to you and you have to calculate the height or length or age, then you need to go in for the inverse function.
This is it for this video. If you have any questions or would like more videos, please leave a comment below and I will get back to you as fast as I can. If this was useful, please click on the like button and subscribe this video for more educational videos.